dimensional analysis problem, we have a situation where we're dealing with squared units. So we're dealing with area, and the steps you're going to take to get the answer are really no different than any other dimensional analysis problem, but you have to incorporate the exponents. And I'm going to do it kind of the long way as I'm showing it to you, but you could do a little bit shorter. I'm just trying to show every little step. So let's set it up here. We said how many gigameters squared. That capital G is a gigameter. How many gigameters squared equals, and what's the given value? 325.2 inches squared. I'm just going to write inches abbreviated squared. All right, so if we first take a look at the problem, we see that it's metric and English. So the first thing I might want to do is determine a connection between a distance unit that's metric and a distance unit that is English. And when we look at our conversion factors sheet, we see right here that 2.54 centimeters equals 1 inch. Now, you could also go down here, 1.61 kilometers equals 1 mile. That's going to make the problem a little longer. So because inches, which is involved in the problem, is part of this conversion factor, that's going to help me out. So I'm going to use that definitely. 2.54 centimeters equals 1 inch. So I have to get from inches squared, and I'm going to ignore the exponents for right now, from inches squared to gigameters squared. And centimeters is going to be my bridging unit. It's going to allow me to get from here to here. We don't have any connection between inches and gigameters on our conversion sheet. All right, so let's imagine we were setting this problem up and we weren't going to use the exponents. We would just put inches down here, and I'd like to put gigameters on the top, but I can't because there's no direct connection between the two values. But I said I was going to use centimeters as my bridging unit, so I'm going to put centimeters up there. What numbers do I put next to the units? Well, inches. I have a 1 there. 1 inch equals 2.54 centimeters. Again, I'm ignoring the exponents. We're going to come back and address those in a second. So we can't cancel anything out yet because we have inches squared and we have inches. So we can't touch that. But I am to centimeters here, and I want to get to gigameters squared. So centimeters on the bottom. And these are both metric units. Gigameters and centimeters are metric units. And when we did just metric converting, we said which one is a bigger value. And if you look on your metric prefixes sheet, you see giga 10 to the 9th here, and you see centi 10 to the negative 2nd. So from 9 to negative 2, how far are we talking? That's 11. So in 1 gigameter, there's 10 to the 11th centimeters. Again, giga is 10 to the 9th, centi is 10 to the negative 2nd. We're just looking at the difference in the exponents. So from 9 to negative 2 is 11 exponents. So I'm going to put 10 to the 11th. So 1 goes here, and 1 times 10 to the 11th goes there. That'd be great if there wasn't any squared value here, because we could go ahead and multiply everything out and divide. But unfortunately, we have to deal with a squared value now. Because I'm dealing with area, I have to make these conversion factors relate to area. So that means I'm going to have to come back and I'm going to have to square each conversion factor. That one and that one. So I'm going to rewrite my brackets down here. That one doesn't change any. What's 1 inch squared? Well, I believe that's 1 inch squared. Easy enough. What's 2.54 centimeters squared? Well, you square 2.54 centimeters, you get 6.4516 centimeters squared. And notice I didn't round this because we can only round at the very end. If I round it here and then I round it again, I'd be rounding twice, and that's not allowed. Well, let's continue on, and we forgot to cancel. So inches squared goes away. Now what's going to go on the bottom? Well, let's let the dimension analysis tell us. 1 gigameter squared and 1 times 10 to the 11th centimeters squared. How do we square exponents? Well, when you square exponents, you just multiply the 2 by whatever the exponent is. So 2 times 11 is 22. So we're going to have 1 times 10 to the 22nd centimeters squared. Centimeters squared cancels. Now what are we left with? We're left with gigameters squared. Where did we want to get? We wanted to get to gigameters squared. So there's no need for any more brackets. And now we just multiply 325.2 times 6.4516 divided by 1 times 10 to the 22nd. And when we do that, we end up with 2.09806 times 10 to the negative 19th gigameters squared. Tiny, tiny number. We would expect that because inches are much, much smaller compared to gigameters. You have to have a whole lot of inches to make up a gigameter, so we'd expect this to be a tiny number. But I haven't rounded yet. When you're rounding, you go back and look at the numbers before you square everything. So these are exact. There's exactly 1 gigameter in 1 times 10 to the 11th centimeters. The given value has 4 sig figs. Always treat that as a measured value. And the 2.54 is a decimal number, and we're going to treat that as a measured value, although some teachers might make you treat it as exact. I'm making you treat it as a decimal number, so it's a measured value. So there's 3 here. 3 here, 4 here. What's the third sig fig in this number? The 9. Next to the 9 is an 8. So the 9 is going to go up to a 10. And that makes this 2.10. But we can't forget our 10 to the negative 19th gigameters squared. And that's how you do a dimensional analysis problem with exponents.